Welcome to Vending University, the ultimate guide to becoming a vending operator and your starting point for mastering one of the most critical challenges in modern vending operations: optimizing load balancing across large-scale vending fleets. As vending networks grow, efficiency, accuracy, and timing become essential to long-term success and profitability. This course is designed to help you understand how load balancing impacts every part of a vending operation, from inventory distribution and route planning to machine uptime and customer satisfaction. Poorly balanced fleets lead to stockouts, wasted trips, higher fuel costs, and missed revenue opportunities that add up quickly at scale. Throughout this course, you will explore how data-driven decisions can transform the way you manage hundreds or even thousands of machines. You will learn how to analyze sales velocity, product demand, and location performance to ensure each machine is serviced at the right time with the right products. We will also focus on practical strategies for balancing workloads across routes and teams. By optimizing delivery schedules and service frequency, operators can reduce operational strain, prevent overservicing, and maintain consistent performance across diverse locations. In addition, this course addresses the role of technology in load balancing. From real-time monitoring to predictive restocking models, you will gain insights into how modern tools help operators anticipate demand instead of reacting to problems after they occur. You will also examine real-world operational scenarios that highlight common bottlenecks and inefficiencies in large vending fleets. These examples will help you connect theory to practice and apply optimization principles confidently in daily operations. By the end of this course, you will have a clear framework for optimizing load balancing in large-scale vending fleets. Whether you manage a growing operation or an established network, these principles will help you increase efficiency, reduce costs, and build a more resilient vending business. Module 1: Foundations of Load Balancing in Large-Scale Vending Operations. In this module, you will be introduced to the core concept of load balancing and why it is essential for managing large-scale vending operations efficiently. Load balancing is not only about filling machines. It is about distributing time, inventory, labor, and resources in a way that maximizes performance across the entire fleet. As vending fleets expand, differences between locations become more visible. Some machines sell quickly, while others move slowly, and treating every machine the same creates inefficiencies. This module explains how imbalance develops and how it quietly increases costs, reduces availability, and puts unnecessary pressure on service teams. You will learn how load balancing connects inventory planning, route management, and service schedules into one operational system. When these elements work together, machines stay stocked, routes stay efficient, and customer demand is met consistently without overservicing or waste. This module also explores the financial impact of poor load balancing: missed sales, excess inventory, higher fuel usage, and unplanned service visits all stem from imbalance. Understanding these costs helps operators see load balancing as a profit driver rather than an administrative task. In addition, you will be introduced to the basic data points used in load balancing decisions. Sales patterns, refill frequency, product turnover, and location behavior form the foundation for smarter planning and long-term optimization. By the end of this module, you will have a clear understanding of what load balancing means in real vending environments. This foundation prepares you to apply more advanced strategies throughout the course, ensuring your vending fleet operates efficiently, scales smoothly, and remains competitive over time. Module 2: Understanding Demand Variability across vending locations. In this module, you will explore how and why demand varies across different vending locations and why understanding these differences is essential for effective load balancing. No two locations perform the same, and assuming uniform demand leads to inefficient servicing and lost revenue opportunities. Demand variability is influenced by factors such as foot traffic, time of day, customer demographics, seasonality, and product relevance. This module explains how these elements shape buying behavior and why recognizing patterns is more valuable than relying on assumptions or averages. You will learn how high demand and low demand machines affect the overall balance of a vending fleet. Over-servicing slow locations wastes time and inventory, while under-servicing fast-moving machines results in empty spirals, frustrated customers, and missed sales. This module also introduces methods for categorizing locations based on performance. Grouping machines by demand level allows operators to adjust refill frequency, product quantities, and service priorities without increasing operational complexity. In addition, you will examine how demand variability changes over time. A location that performs well today may decline later, while others may grow unexpectedly. Understanding these shifts helps operators stay proactive instead of reacting to shortages and complaints. You will also learn why external changes such as staffing levels, business hours, or nearby competition can rapidly alter demand patterns. Recognizing these signals early allows operators to rebalance service plans before inefficiencies impact the wider fleet. By the end of this module, you will be able to identify demand patterns across your vending locations and understand their impact on load balancing decisions. This knowledge sets the stage for smarter inventory planning, better route efficiency, and more consistent performance across large-scale vending operations. Module 3: Sales Velocity Analysis for Smarter Machine Servicing. In this module, you will learn how sales velocity serves as a critical indicator for making smarter servicing decisions across large-scale vending fleets. Sales velocity measures how quickly products sell, and understanding this rate allows operators to align service timing with actual machine performance. Sales velocity goes beyond total sales numbers and focuses on speed and consistency. A machine with moderate sales but fast-moving products may require more frequent visits than a machine with higher overall revenue but slower turnover. This module explains why velocity is often more actionable than raw sales data. You will explore how sales velocity impacts refill schedules, product quantities, and service priorities. Machines with high velocity demand tighter servicing windows to prevent stockouts, while slower machines benefit from extended intervals that reduce unnecessary labor and transportation costs. This module also introduces practical methods for tracking and interpreting sales velocity data. By reviewing historical sales trends, refill intervals, and depletion rates, operators can identify which machines drive urgency and which allow flexibility within a route. In addition, you will learn how sales velocity changes based on product mix and placement. Certain items may sell faster at specific locations, and recognizing these patterns helps operators adjust assortments to maintain balance without increasing service frequency. You will also understand how sales velocity supports forecasting and proactive planning. Anticipating when products will sell out allows operators to schedule service before problems occur, reducing last-minute interventions and improving overall route stability. By the end of this module, you will understand how to use sales velocity as a foundation for smarter machine servicing. Applying these insights enables more efficient routing, fewer emergency refills, and better load balancing across the entire vending fleet, even as operations continue to expand. Module 4: Inventory Distribution Strategies for Fleet Efficiency. In this module, you will explore how strategic inventory distribution forms the backbone of efficient large-scale vending operations. Ensuring that every machine has the right products in the correct quantities is essential not only to avoid stockouts, but also to reduce waste, unnecessary trips, and missed revenue opportunities across the fleet. You will learn how to calculate optimal stock levels for each machine based on demand patterns, sales velocity, location type, and historical performance. Machines in high-traffic areas require more frequent replenishment and larger quantities, while slower locations can maintain minimal stock, reducing both storage needs and labor costs. This module also highlights the importance of categorizing products by priority, demand, and margin contribution. By focusing on high turnover, high margin products, operators can maximize revenue while maintaining variety. At the same time, low demand items should be distributed selectively, ensuring machines remain appealing without overfilling and increasing the risk of expired or unsold products. Dynamic redistribution is another key focus of this module. You will learn how to shift inventory between machines or adjust refill quantities in real time, responding to sudden changes in demand caused by seasonal trends, special events, or shifts in local traffic. This proactive approach prevents shortages and avoids excessive trips, making operations more cost-efficient. Forecasting and historical data play a major role in smart inventory distribution. By analyzing past sales trends, consumption patterns, and even external factors like weather or nearby competition, operators can predict demand with greater accuracy. This foresight allows for well-planned refill schedules that keep the fleet balanced while minimizing last-minute adjustments. By the end of this module, you will understand how to design and implement inventory distribution strategies that enhance efficiency and profitability. Applying these principles will ensure that your vending fleet maintains optimal stock levels, improves service consistency, reduces waste, and ultimately maximizes both customer satisfaction and operational performance. Module 5. Route Optimization and Service Frequency Balancing. In this module, you will learn how route optimization and service frequency directly impact efficiency and cost-effectiveness in large-scale vending operations. Optimizing routes ensures that machines are serviced in the most logical sequence, minimizing travel time, fuel consumption, and labor costs while maintaining high product availability. You will explore methods for analyzing route data, including distance, traffic patterns, and service priorities. Understanding these factors allows operators to plan routes that reduce redundancy, avoid unnecessary backtracking, and ensure that high-demand machines are serviced promptly, while slower locations are visited less frequently. Service frequency balancing is equally important. Machines with high sales velocity require frequent visits, while low-demand machines can be scheduled for longer intervals. This approach reduces strain on service teams, prevents over-servicing, and ensures that resources are allocated where they are most needed. This module also introduces techniques for combining multiple routes efficiently. Operators will learn how to group machines geographically and by service priority to create balanced daily routes that maximize coverage without overloading staff or vehicles, ensuring fleet-wide efficiency. In addition, you will learn how to incorporate real-time adjustments into route planning. Unexpected demand spikes, machine malfunctions, or traffic disruptions can be managed proactively by using dynamic routing tools, allowing operators to maintain service quality without excessive delays or costs. By the end of this module, you will have a comprehensive understanding of how to design optimized routes and balanced service schedules. Implementing these strategies ensures that your vending fleet operates efficiently, reduces operational costs, and consistently meets customer demand across all locations. Module 6. Using real-time data to prevent stockouts and overfilling. In this module, you will learn how real-time data monitoring transforms large-scale vending operations by preventing stockouts, overfilling, and unnecessary service trips. Access to up-to-date information allows operators to make proactive decisions, improving machine availability and customer satisfaction. You will explore how sensors, telemetry, and point-of-sale data provide insights into product levels, sales velocity, and machine performance. By monitoring these metrics continuously, operators can identify machines that are at risk of running out of stock or carrying excess inventory that could lead to waste. This module also examines how real-time alerts and dashboards support faster response times. When a machine signals low stock or unexpected high demand, operators can prioritize service routes dynamically, ensuring the most critical machines are refilled promptly while avoiding unnecessary trips to fully stocked machines. In addition, you will learn about predictive restocking based on real-time trends. Combining historical sales data with live performance metrics allows operators to forecast needs more accurately, preventing both shortages and overstock situations before they occur. You will also understand how real-time data supports fleet-wide balance. Operators can compare performance across locations, redistribute inventory if necessary, and adjust refill schedules to maintain consistent service levels across all machines, regardless of size or location. By the end of this module, you will be able to leverage real-time data to make proactive operational decisions. Applying these tools ensures your vending fleet maintains optimal inventory, improves efficiency, reduces waste, and delivers a consistently satisfying experience for customers. Module 7. Workforce and route load balancing for service teams. In this module, you will learn how to balance workloads effectively across service teams to maintain efficiency in large-scale vending operations. Proper workforce allocation ensures that routes are completed on time, machines remain stocked, and employees are neither overworked nor underutilized. You will explore how to assess team capacity, route complexity, and service frequency when assigning tasks. Matching the right number of staff to each route prevents bottlenecks, reduces overtime costs, and ensures that high-demand machines receive attention without unnecessary strain on slower routes. This module also covers strategies for distributing labor based on location performance. By analyzing historical service times and sales velocity, operators can identify which routes require more effort and which can be combined or serviced less frequently, optimizing both manpower and efficiency. In addition, you will learn how to monitor team performance and make adjustments in real time. Unexpected events such as vehicle issues, staff absences, or sudden spikes in demand can be managed effectively when workloads are balanced and teams are adaptable, maintaining service consistency across the fleet. You will also explore scheduling techniques that align staff availability with peak demand periods. Flexible scheduling, route rotation, and shift adjustments allow operators to maintain productivity while keeping employees engaged and reducing burnout, which is critical for long-term operational stability. By the end of this module, you will understand how to create balanced service schedules that optimize team performance, maintain consistent machine uptime, and improve overall fleet efficiency. Proper workforce and route balancing is key to sustaining growth and meeting customer expectations across a large vending network. Module 8. Technology Tools for Predictive Restocking and Scheduling. In this module, you will explore how modern technology tools can transform load balancing in large-scale vending operations. Predictive restocking and intelligent scheduling software allow operators to anticipate demand, optimize routes, and maintain machine uptime more efficiently than traditional manual methods. You will learn how data analytics platforms integrate sales data, inventory levels, and historical trends to forecast when and where machines need service. By using predictive models, operators can reduce emergency visits, prevent stockouts, and minimize overfilling, creating a more cost-effective and reliable operation. This module also covers route planning software that factors in machine location, traffic patterns, and service priority. By automating scheduling and optimizing sequences, operators can reduce travel time, fuel usage, and labor costs while ensuring that high-demand machines are always prioritized for service. In addition, you will explore mobile applications and dashboards that provide real-time visibility into fleet performance. Service teams can receive live updates on inventory status, machine alerts, and route changes, allowing for immediate adjustments that keep operations running smoothly. You will also understand the benefits of integrating multiple technology tools to create a cohesive system. Combining predictive analytics with real-time monitoring and automated scheduling ensures that load balancing decisions are data-driven, proactive, and scalable as the fleet grows. By the end of this module, you will be able to leverage technology effectively to improve predictive restocking and scheduling. Applying these tools enhances operational efficiency, reduces costs, maintains consistent service levels, and positions your vending fleet for long-term growth and scalability. Module 9. Identifying and resolving load. Imbalances in expanding fleets. In this module, you will learn how to detect and correct load imbalances that naturally occur as vending fleets grow. Expanding operations often introduce inefficiencies, with some machines overserviced and others underserviced, leading to wasted resources, lost sales, and inconsistent customer experiences. You will explore key indicators of load imbalance, including frequent stockouts, excessive inventory, irregular refill schedules, and service team overload. Recognizing these signs early allows operators to take corrective action before small inefficiencies escalate into larger operational problems. This module also covers practical methods for analyzing fleet-wide performance data. By comparing sales velocity, refill frequency, and inventory levels across locations, operators can pinpoint which machines are causing strain and adjust service plans or inventory distribution accordingly. In addition, you will learn strategies for resolving imbalances, such as redistributing stock, reassigning routes, and adjusting service frequency. Implementing these changes in a structured manner ensures that all machines operate efficiently without overburdening staff or creating gaps in coverage. You will also understand the importance of continuous monitoring and iterative adjustments. Load balancing is not a one-time task. Fleets change over time due to seasonal trends, new locations, or shifts in customer behavior, requiring ongoing analysis and fine-tuning to maintain optimal performance. By the end of this module, you will be able to identify load imbalances quickly and implement targeted solutions to maintain fleet-wide efficiency. These skills ensure that as your vending operation grows, it remains well-balanced, cost-effective, and capable of delivering consistent customer satisfaction. Module 10. Building a scalable load balancing framework for long-term growth. In this module, you will learn how to create a comprehensive load balancing framework designed to support long-term growth in large-scale vending operations. A scalable framework ensures that as your fleet expands, machines remain well-stocked, service teams operate efficiently, and overall performance stays consistent. You will explore the core components of a scalable framework, including standardized inventory allocation, optimized routing, demand forecasting, and performance monitoring. By integrating these elements, operators can maintain balance across hundreds or even thousands of machines without increasing complexity or operational strain. This module also covers the importance of flexibility and adaptability. A robust framework accounts for changing demand patterns, seasonal fluctuations, and unexpected disruptions, allowing operators to adjust service frequency, route assignments, and inventory distribution without compromising efficiency. In addition, you will learn how technology, data analytics, and predictive modeling support scalability. Automating key decisions and leveraging real-time insights enables proactive management, reduces manual intervention, and ensures that the framework grows alongside the operation. You will also examine case studies of large vending networks that successfully implemented scalable load balancing strategies. These examples highlight best practices, common challenges, and actionable solutions that can be adapted to your own operation for long-term success. By the end of this module, you will have the knowledge to design and implement a load balancing framework capable of sustaining growth. Applying these principles ensures your vending fleet remains efficient, resilient, and profitable, providing a solid foundation for future expansion and operational excellence. Conclusion: optimizing load balancing is a critical component of running a successful large-scale vending fleet. Throughout this course, you have explored the principles, strategies, and tools required to ensure each machine operates efficiently, inventory levels are maintained, and service teams are used effectively. Understanding these concepts is essential for operational excellence and long-term profitability. One key takeaway is the importance of data-driven decision-making. By analyzing sales velocity, demand variability, and historical trends, operators can allocate resources intelligently, predict inventory needs, and adjust routes and schedules proactively. Relying on assumptions or static plans can lead to inefficiencies that affect revenue and customer satisfaction. Another major insight is the value of integrating technology into fleet management. Real-time monitoring, predictive analytics, and automated scheduling tools allow operators to respond to changes quickly, prevent stockouts, reduce overfilling, and maintain service consistency. These tools streamline operations and provide actionable insights for improvement. Effective workforce and route management also play a central role in balancing loads. Assigning teams properly, balancing workloads, and scheduling visits based on location performance ensures labor is used efficiently, machines are serviced on time, and operational costs are minimized. Well-planned management supports both employee satisfaction and fleet performance. Building a scalable framework is essential for long-term growth. As fleets expand, maintaining balance across all machines requires standardized processes, flexible strategies, and ongoing monitoring. A strong framework allows operators to adapt to changing demand, integrate new locations smoothly, and maintain efficiency without adding complexity. By applying the principles covered in this course, operators will be equipped to optimize load balancing across large vending fleets. These strategies enhance efficiency, reduce costs, improve customer experience, and create a foundation for sustainable growth. Mastering load balancing transforms operations from reactive management into a proactive, data-driven system capable of supporting current operations and future expansion.